Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to learn a new topic, which is probability distribution function and probability densities. But for this chapter, we're going to focus on discrete probability distribution. Under discrete probability distribution, we will learn a probability distribution for discrete random variable, and of course we will get introduced with random variable, and then we're going to look up on expectation, mathematical expectation, and the last one is a special probability distribution, such as binomial distribution and Poisson distribution. Right, so if you can see my screen here. So in any experiment, there are numerous characteristics can be observed or measured. In most cases, experimenter, dia kata kat sini, experimenter boleh buat apa? Experimenter will focus on the specific aspect or aspect of the sample. So means that we want to focus on something. For example, if you want to do a survey on knowledge, attitude, and practice on dengue fever prevention. So you want to focus on what? You want to focus on knowledge of dengue fever prevention, the attitude of respondent on dengue fever prevention. Let's say you do one experiment. Let's say you roll a die, ataupun let's say you toss a coin, for example. You want to know what is the probability of getting head, right? So your interest is to know what is the probability of getting head, right? So head is your interest lah. So now, if you, in general, kita baca lagi. In general, each outcome of experiment can be associated with the number by specifying a rule of association. So such rule of association is called as a random variable, right? Random variable. So something that you are interested to find, we call as random variable. So usually random variable is denoted by uppercase letter near end of the alphabet lah. Normally lah. You can use others alphabet, but it should be on capital letter. Either you can use X, Y, or Z. Right? So the definition of random variable is a numerical value function defined over a sample space. So sample space, let's say you toss a coin. So sample space for tossing a coin should be either head or tail, right? Things that you want to know. Let's say you want to know, you are interested on number of head, right? So number of head is your random variable. So you can note your random variable as X, capital X, or capital Y, or capital Z, or you can use others alphabetical alphabet word yang you nak pakai, letter yang you nak pakai. Tapi normally we are using dia kata kat sini using uppercase near end of the alphabet, right, such as X, Y, or Z. Now let's look at example number 3.1 in your book. Right, so a coin is tossed twice. Right, so we toss a coin twice. So the sample space S will be HH, HT, TH, and TT. Where do you get this one? You can get the samples, the full possible outcome by drawing a tree diagram kan. Remember last chapter kita belajar tree diagram. Let's say the first toes you got head and tail. This is first toes. Second toes, if your first toe you got head, second toes tail, there are two options, either head or tail. Same goes to tail. So the sample space here should be head, 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 tail, tail, head, and tail, tail. Right. So, so dekat sini dia kata, let Y represent the number of head that come up. So this alphabet will represent random variable. So random variable, your random variable is number of head. Right. So I hope you understand lah. I just want to emphasize on random variables saja. Definition of random variable. Random variable means that something that you are interested to know. Right. So another example, you tengok dekat sini. Let's say you have a student body. So dalam population of student body, you have a lot of student here. Then you take one student out. So take one student out called as a random experiment. Right. So you select one student out, it's called as a random experiment. So you are measuring student height, weight, family income, GPA, CGPA. This is what we call as a random variable. Alright. So it's same as the concept of variable of interest as we already learned in chapter number 1. Right. So, but here in this chapter, we call it as a random variable. So there are two types of random variable. First is a discrete random variable, and second one is a continuous random variable. So random variable. So we have two types of random variable, discrete random variable and continuous random variable. Discrete random variable means that it only takes discrete number. Discrete value means that the value cannot have a decimal point. So let's say you want to know number of children. So it can be either 1, 0, 1, 2, 3, 4, 5, 6, right? So it should be in whole number, right? So this is lies under discrete value lah. For continuous value, right? Continuous random variable, it can take a decimal point, right? The value should lies in one range. So contoh, let's say you are measuring height of the student. So height of the students can be either from 0 to 200 centimeters. So from 0 to 200 centimeters are any value within this range are possible, right? So I hope you already understand, because we already discussed about discrete and continuous number in previous chapter. Remember quantitative variable, we have the discrete quantitative and continuous quantitative. So for discrete quantitative means that it only takes a whole number. For continuous quantitative, it can the value can be measured, right? It should lies between a range, right? So the any number, any value within that range are possible. Boleh lain-lain you baca dekat sini lah. So now let's focus on a discrete random variable, right? So to emphasize, to remind you, once you already finished this chapter, you should expect test number 1 lah. So probability distribution for discrete random variable. So I hope you are already clear about the random concept of random variable, the definition of random variable. Again, random variable means that something that we are interested to find, right? But in this case, we are focusing on discrete random variable. Discrete random variable means that something that we can count, and the number should be in whole number, cannot be in decimal number, right? So I hope you all understand. So we focus one by one. After this chapter, we will focus on continuous. for discrete random variable, probability distribution for discrete random variable. So the definition, if X is a discrete random variable, right, capital X, remember, the notation is capital letters. The function given by fx equal to probability of x equal to x. So nampak dekat sini, this is random variable and the small letter x is what we call as a random number, right? You just kita letak dekat sini, kita letak satu perkataan random sajalah. We know that this is what we will represent variable x, small letter x will represent number lah. For each x within range of x is called a probability function or probability distribution function, right? Probability distribution function ataupun this is what we call as a PDF. Kalau you tengok most of the book will say will use a notation PDF to represent probability distribution function for discrete random variable. PDF of x should be equal to probability of x equal to small letter x. So this is what we call as random number and this is what we call as random variable, right? The theorem, the rule of probability distribution function still hold the original rule of probability. What is the original rule of probability? We have two original rule of probability. The first one, probability should lies between 0 and 1. And the total of all probability in one sample space should be equal to 1. Alright, same concept. Right, so dia kata dekat sini fx or PDF must be more than or equal to 0 or less than or equal to 1. Dia mesti masuk dalam range ni lah. Fx should be less than 1 or more than 0. Right, this is the first concept. The second concept is, the second rule is the summation of fx should be always equal to 1. Okay? Ada soalan tak dekat ni? Alright. I hope you understand the rule of probability. Now let's look at example number 3.3. Find the probability distribution function of x for x where x is a total number of head obtained in 3 toes of balanced coins. First step is we need to let's say I start from scratch. So we have a coin with toes 3 times, right? So first we need to find a sample space lah. First, let's say for first toes we have head and tail. So this is the first toes. If the first toes you have head, then second toes you also have two options, either head or tail, right? Same goes to tail, right? This is for second toes. This is the first toes. This is the second toes. For the third toes, if the first toes you got head, second toes you got head, the third toes also head or tail. Because there are only two possible outcomes for tossing a coin. Right? So same goes to others. Right. Now, so since you already construct a tree diagram, so now sekarang ni you buat a table, right? Make a table because you want to construct a probability distribution function for a discrete random variable. So what you need to have here is your sample space, right? Possible outcome, and then we're going to create a probability. Ataupun what we call as probability of Probability lah. And this is your random variable. Right? This is a random variable. Right. Now, kita focus one by one. So, first one, we have head, head, and head. The second one, we have head, head, and tail. Right. I'm showing you how to construct a probability distribution function for a discrete random variable from scratch. Right. So, head, tail, head. And this is going to be head, tail, and tail. And this is tail, head, head, tail, head, tail, and this is tail, tail, head, and the last one is going to be tail, tail, and tail. So now we want to find probability of the event, right? So this one kita ada berapa? 1, 2, 3, 4, 5, 6, 7, 8. So kalau kita tengok triple H here, so ada berapa kali ulangan triple H? Sekali saja kan? So this is going to be 1 over 8. Right? This is also 1 over 8, 1 over 8, 1 over 8, and so on lah. Semua sekali-sekali saja kan? Ada ulangan lain tak? 1 over 8, and this is also 1 over 8. And the total, right? Remember the rule of probability, the total of all probability should be equal to 1. Dan tambah semua ni mesti sama dengan 1 lah. So now, apa yang kita nak cari sebenarnya? Oops, kenapa dia tak nak pergi? So dia nak cari, we want to find the probability distribution function for x, where x is the total number of head obtained in 3 toss of balanced coins. So dekat sini, number of head for the first sample, first event number of head ada 3. Number of head 2, 2, 1, 2, 1, 1. This is 0. Right? So this is a random number. Right? Our random variable. So now, next step is we create a probability distribution function. Distribution table lah, probability distribution table. To summarize all the result we have found in tree diagram. So we have capital X equal to X. This is what we call as a random number. So equal to X means that we're going to summarize how many head we found in the table. And this is the probability of X equal to X. So we have here, dekat sini, number of head 0, 1, 2, and 3. So we're going to conclude we found 0, 1, 2, and 3. And the last one, the last column should be total lah. Right? For probability of x equal to 0, we only found 1 x equal to 0. So this going, the probability should be 1 over 8. Dekat sini. Right? So for x equal to 1, kita jumpa 1, 2, 3. So we're going to add up 1 over 8, 1 over 8, and 1 over 8. Should be equal to 3 over 8. For x equal to 2, 1, 2, 3. Sama juga. 3 over 8. Tambah semualah 1 over 8 plus 1 over 8 plus 1 over 8. Right? For x equal to 3, we have only one x equal to 3. This is equal to 1 over 8. Right? So kita ambil this one lah. So the total should be always equal to 1. Tambah semua sama dengan 1. So this is what we call as probability distribution table for discrete random variable. Right. So example semua dah bagi kat sini lah jawapan. Right. Now let's look at two socks are selected at random and removed in succession from a drawer contain five yellow socks and three blue socks. Find the probability distribution for X equal to number of yellow socks. So our random variable is number of yellow socks. Right? So basically the same concept, right? First, you draw a tree diagram. To get the element of sample space, draw a tree diagram. Let's say for the first toast, let's say you going to select two socks from a drawer, right? First selection, right? Let's say you have yellow socks and blue socks. Let's say first socks you nak ambil, dia tak kira pair kan. Kita ambil first socks, kita nak ambil yellow. This is the first pick. So for first pick, we have yellow and blue. Let's say for the first pick, you already took yellow socks. For if you took a yellow socks, second pick, they are still have two options, either blue or yellow. Right? So you should listen this one carefully, this chapter carefully, because this is a bit confusing and need more attention, right? So let's say for the first toast, first pick, you ada dekat sini berapa? 5 out of berapa? We have 5 and 3. So the total here should be equal to 8. 5 over 8. Right? And for the blue sock, you have 3 over 8. If the first pick, you already picked yellow socks. The second pick, yellow ada berapa? 4 over 7. 4 over 7. And this one, for blue socks, you are going to have 3 over 7. Same goes to this one. So this one should be 5 over 7. And this is going to be 2 over 7. Right? So now you create a table like this. So you senaraikan the sample space. This is going to be YY, YB, BY, and this is BB. Right? So nampak senaraikan macam ni. And then put all the probability inside the probability column. Right? So how to get the probability? You just multiply these two together. So you're going to get the intersection kan. 5 over 8 multiply with 4 over 7. So you will get 5 over 14. 15 over 56. 15 over 56. And last is 3 over 28. And then you put the second, for the third column, you letak, this is your random variable. Random variable is the number of yellow socks selected. So this is 2, 1, 1, 0. So you letaklah 2, 1, 1, 0. Right? So then baru you construct a probability distribution for y and for x. Right? So you have 0, 1, and 2. So you letak 0, 1, and 2. Right? And this is a total lah. Total. Right? And then for 0, you only have 3 over 28. For 1, maksudnya tambah 2 ni. Right? 15 over 56 tambah 15 over 56. So you will get 15 over 28. And the last one, you only have 1. So you letak lah. This probability value letak saja. Okay? I hope you understand. Any questions so far before we proceed? So yang mana belum tak buka webcam, tolong buka webcam. Right? So now, let's look at example number 3.5, right? 3.5. So determine whether the function given fx x equal x plus 2 divided by 25 equal to 1 for x is 1, 2, 3, 4, 5 can serve as a probability distribution function, right? Back to the rule of probability, right? A probability distribution function is said when x is said to have so dia kata kat sini mana dia punya the function can serve as probability distribution function of a discrete random variable x if and only if the value of x fx satisfy the following condition. The first condition is fx should lies between 0 and 1. And then the summation of fx should be equal to 1. That's the rule, theorem number 1. So this theorem you should remember, right? So to answer example number 3.5, you going to refer to theorem number 1. First step, you're going to test fx equal to x plus 2 over 25. Let's say for x equal to 1, right? For when fx x equal to 1, so this is 1 plus 2 divided by 25. So this one should be 3 over 25. So 3 over 25 is between 0 and 1, right? So first condition should be okay. Then you should test for the rest lah. And then for the best presentation lah, you nak test means you buat table lah, senang. Right? Let's say you buat table. You buat table, senang nak nampak. You need to test every number, right? Every random number, you buat table. X equal to small letter x, probability of x equal to x. From 1, 2, 3, 4, and 5 total. Right? So for x equal to 1, so it should be 3 over 25. For x equal to 2, 4 over 25. X equal to 3, 5 over 25. X equal to 4, 6 over 25. And the last one is 7 over 25. The total here should be equal to berapa ni? What is the value of the total? So 3 plus 4 plus 5 plus 6 plus 7 should be equal to 25. So 25 over 25 equal to 1. So since each of value of fx is between 0 and 1 and the total of fx is equal to 1, so we can say that fx equal to x plus 2 over 25 for x equal to 1, 2, 3, 4, and 5 is a discrete probability distribution function, right? Okay. Sama je lah, I ada explain dekat sini. Now let's look at the last example before we move to expected value, right? So example number 3.6. A mail order computer business has 6 telephone line. Let X denote the number of line in use, right? So you need to take note your random variable, right? Always take note your random variable. Always highlight your random variable, right? Suppose the probability distribution function of X is given in the accompanying table. So dekat sini dia represent apa? This is representing number of line in use. 1, 2, 3, 4, 5, 6. Right? And this is the probability. And before you answer the question, you should look at the total. So we already know that these values are between 0 and 1. Always look at the total. So total up, this one should be equal to berapa ni? What is the value of the total?
One.
Speak up. Berapa?
One, sir. One, sir. One.
So what is the value here?
One, sir.
Alright, good. So now, calculate the probability of each of the following events. So at most 3 lines are in use. So probability of x less than or equal to 3. So this one should be, you need to add every probability value lah. Probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. So this one should be 0.1 plus 0.15 plus 0.2 plus 0.25. And then this is should be equal to 0.7, right? Now B, probability of fewer than 3 lines are in use. Probability of x less than 3. It means that probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So 3 not inclusive, right? So fewer than 3. So you tambah semua ni, you will get 0. Berapa? 0.45. Is it correct? Right. For C, let's say at least probability of x more than or equal to 3. So at least 3. So means that you need to add from 3 until 6. Right. So probability of x equal to 3 plus until probability of x equal to 6. Right. And then for D, between 2 and 5 lines, means that probability of x, x dekat tengah-tengah ni. So dia kata dekat sini inclusive. Kalau dia tak sebut inclusive, means tak masuk lah. Inclusive 2 and 5. So maksudnya, you akan tambah from 2 to 5. You tambah 2, 3, 4 and 5. Okay. 0.2 plus 0.25 plus 0.2 plus 0.6. Okay. This is how we answer the question. Right. Oh, I think soalan ni kita dah buat tadi kan? Two songs are selected at random and remove succession drawer. Kita dah buat dah. Okay, no worries. Let's look at this question. Okay. Question number 2 from your final exam question. I tak ingat tahun bila, but I just copy and paste. So now, question number 2A, right? So the number of students using big data lab per day is shown in the distribution table below, right? So we have 6, 8, 10, 12 and 14. So what is the definition of x here? What is our random variable? Before we answer the question, we need to understand what is our random variable. So our random variable here is apa?
The number of students.
Number of students using big data lab. So number of students using big data lab. So this is your random variable. So now the question asks us to determine the value of m, right? To determine the value of m, this is going to be very easy because we already know from the theorem, right? The probability distribution function should always, the value of probability distribution function should always be between 0 and 1. The second theorem is the summation of all probability should always equal to 1. So we put total here, right? And the total here should be always equal to 1, right? So you nak cari m ni senang saja kan? So 1 minus 0.3 0.15, right? Tolak je lah semua. 0.15 plus 0.30 plus 0.1 plus 0.1. So 1 minus this one, you should get value of m. Right? So berapa value dia? What is the value of m? 0.35. Right? Okay, good. So for second question nanti kita masuk. Now let's look at the right. So can you calculate this one? The probability of distribution of y is given as follows. So the probability of y equal to 7, 8, 9, 10, 11. So 15 for 7 is 0.15. For 8 we don't know. For 9 also don't know. 10 is 0.22 and 11 is 0.15. So in this condition, we should they did not give us any additional information whether 8 is double of 9 or 9 is double of 8, right? So we can assume that m is shared the same number. 8 and 9 are sharing same probability value, right? So 3 minutes you have to solve this problem. So what is the value of m? Senang saja kan? Tak susah pun. First step, make a total. Total should be always equal to 1, right? And then to find m is equal to 1 minus 0.15 plus 0.22 plus 0.15, right? So this value should be equal to berapa ni? 0.48, right? So m, here we have 2m equal to 0.48. So m should be equal to 0.24, right? So this is basically a shortcut lah. So for a long cut means that for if you don't really understand this concept, so just put like this: 0.15 plus m plus 0.22 plus 0.15 should be equal to 1. and the total here should be 2m plus 0.58, sorry, 552, right? Is it 0.15 plus 0.15 plus 0.22, 0.52. 52 equal to 1. So 2m equal to 1 minus 0.52 should be 2m equal to 0.48, m equal to 0.24. So this is the standard calculation lah, right? So this is basically a shortcut. So now, what do you expect from this question? Nampak dekat sini ada 5 markah kan? So I did not expect the answer, your working mathematical work should be like this lah. Your mathematical work should be arranged like this. This is the second one, right? Jangan buat shortcut lah, right? So depend on marks, right? Kalau you tengok dekat atas ni, marks 3 marks. So maybe you can do like this lah. But for 5 marks, maybe I don't think you can do like this. Just write down the proper mathematical work, right? So now let's look at example question number 2. Right, question number 2. The number of defective mobile phone in batch of production is given by the following distribution, right? So basically it's the same concept, right? So we want to find the value of W, and first step is you should know that all the total of all probability should be equal to 1. So you ambil 1 is equal to 2W plus 0.25, 0.25 plus 0.14 plus 0.11 plus W minus 0.1. Right? So this one you tambah dulu yang numerical value lah, yang ada value. This is going to be 0.25 plus 0.14 plus 0.11. So 0.5. Right? So tapi kalau tengok dekat sini, kita boleh manipulate sikit kat sini kan. So instead of buat macam tu, kita buat macam ni. Right? So we have 2W, kita bawa W ni dekat depan juga, tambah dengan W. So tambah 0.25 plus 0.14 plus 0.11. This is plus minus should be equal to minus, right? So dekat sini nampak tak? Plus minus should be minus. So minus 0.1. Right? So this one should be 3W plus 0.25 plus 0.14 plus 0.11 minus 0.1. It should be equal to 0.4, equal to 1. Right? So 1 minus 0.4 is 0.6 equal to 3W. So 3W equal to 0.6. Right? So bawa ke sini, tempat tak ada. So W should be equal to 0.6 over 3. So W should be equal to 0.2. Right? 0.2. So now dah dapat 0.2 equal to W. Masukkan dalam table. Masukkan dalam table. Right? So dekat sini, okay. 0.2 multiply with 2 is 0.4. 0.25, 0.14, 0.11, 0.2 minus 0.1 is 0.1. So the total should equal to 1, 0.25. Sama dengan 1 tak? Kalau tak sama dengan 1 means something wrong with this calculation. Alright? Are you okay? Boleh faham, eh? Should be very simple. Right, expected value, kejap lagi kita masuk. Now, let's look at is next question. Alright. The number of connection on the internet during 2-minute period is given as the following distribution. So X random variable is number of connection 0, 1, 2, 3, 4. This is the probability of X, right? So before we answer the question, try to look at the value of the probability distribution. Semua mesti between 0 and 1. And the total should always equal to 1. Kalau tak sama, maksudnya apa? You pangkal soalan ni, soalan salah. Right? So, always equal to 1. Right? Sama dengan 1 tak? Ya, sama kan? So, find the probability that there is more than one connection on internet during 2-minute period. So, this is during 2-minute period kan? Tak jauh kan? Sama je. So, probability of X is more than 1. Which is 1 is not inclusive. So, this one should be probability of X equal to 2 plus probability of X equal to 3 plus probability of X equal to 4. Right? So, never skip any working mathematical works. So, metodologi dia mesti tulis lah. Sebab permakahan ni mesti ikut apa yang you letak lah. Kalau you skip means you letak jawapan terus. Mana kita tahu you jawab betul ke tak, ataupun you tiru jiran sebelah ke, right? So this one should be 0.1 plus 0.2 plus 0.1 should be equal to 0.4. Okay? Boleh? Bawah ni apa? Okay, right. Boleh ada soalan tak? You want to continue or you want to stop here? Are you okay? Any questions so far? Before you want to continue or you want to stop?
I think going up to you, sir. Up to you.
Siapa yang cakap tadi tu?
Saya, sir.
Sebelum you, siapa tu? So I think that's all lah. We stop here. Mana I punya ni? Right, I think that's all. We stop here. Next class we continue on expected value on discrete random variable. Right. So and then after we continue on, we finish on expected value, then we will continue on cumulative function or cumulative distribution function. Right. Thank you very much. Assalamualaikum.